Okay, so let's look at some examples. So we want to first plot the x and y intercepts and look at all of this information, the degree, turning points, a value, which will tell us about the end behavior, and so on. So looking at this, I can see that I have x, oh geez, and that's going to be 1x. There's one more, and then this counts as 2. So that makes a total of 4 as our degree, which means that there will be 3 turning points. The a value looks to be a positive 1, because I don't see it there. And that means that for an even degree with a positive a value, oh, oops, I forgot I deleted it. We're going to have positive, positive. So positive infinity, positive infinity. Since this is in factored form, I will calculate the end behavior, the x-intercepts pretty easily. I've got x equals 0, which is just 0, 0 for this first one. Then x plus 8 equals 0. So negative 8 plus 8 equals 0. And then something take away 2 is 0. 2 take away 2 is 0. And I might say that this one has a multiplicity of 2. And remember that multiplicity of 2 is going to create the bounds. The other two are first degree, and you can tell because there's no exponent indicating second or third degree. So they will just pass right on through. Now finding the y-intercept in this case is pretty easy. Do you see it already? Yeah, it's right here. It's 0, 0. Typically, we would plug in 0 as the x value, but because I saw that 0, 0 was already an ordered pair with 0 for x, that meant I didn't have to. So first I'm going to plot the x-intercepts. I'm going to plot negative 8, 0, 0, and then 2, 0. I'm going to sketch the end behavior. So that's going to be positive and positive. And from there, I'm going to try to connect the dots, noting that this one is a bounce. So it's going to pass through, nope, it's going to just be tangent there, so it will not pass through. So pass through here, and then I have to turn to bounce right there. Ooh, okay. Turn to bounce right there. Well, I did my best, and so will you. So it looks pretty good. The end behavior matches, the x-intercepts match, and we have the appropriate shape at each x-intercept. Cool, let's look at number 2. Dang, this one is needing to be factored. So I can tell right away it's a third degree because that's the highest exponent, meaning there will be 2 turning points. And the a value with the lead coefficient is 1. So always look at the lead coefficient for the a value when it's not in factored form. Otherwise, we look to see if it's there. And so with a positive a value, we're going to have x and y are going to be going towards the same direction. So as x goes towards negative infinity, y goes towards negative infinity. As x goes towards positive infinity, y goes towards positive infinity. So the y values go in opposite directions, but with a positive a and an odd degree, the ends go together, the positive to positive and then the negative to negative. So now to find the x-intercept, we're going to have to do some factoring. So this one is factoring by grouping because it's a polynomial. So you got the x squared, the x minus 3, take out a negative 4, x minus 3 then. So it's going to be x squared minus 4 times x minus 3, which factors further to x plus 2, x minus 2, and then x minus 3. So this tells me that I have my x-intercepts at, okay, so if I start here, something plus 2 is 0, negative 2. Something minus 2 is 0, positive 2. Something minus 3 is 0. And that will do. Okay, so then to find the y-intercept, we are going to plug in 0, but notice how it's going to work. When we plug in 0 here, we get 0. When we plug in 0 here, we get 0. When we plug in 0 here, we get 0. So you can see the y-intercept is 12. 0, 12 technically is off my graph. I'm just going to plot it right here. And then I'm going to plot these other values, -2, +2, and +3. I'm going to sketch my end behavior, -infinity and +infinity. And then I connect the dots. Yay, not bad, okay? Oh, oops, what dot did I forget? Wrong. So I'm going to bring this one a little bit closer. Yep, pretty good. So I use those arrows just to kind of indicate which quadrant my end behavior should be in. Looks okay. All right, and then I think this is our last example. So let's try it. I see that the degree is 3 again, which means there will be 2 turning points. And again, I have an a value of +1. So with the positives and odd degree, the x and y values goes towards the same direction. And I do have to do factoring to find the x-intercepts. So I'm going to factor out the GCF of x. It's going to be x squared minus 3x minus 4. And when I make my t-chart, it's going to be -4 and +1. And that's going to factor to x minus 4, x plus 1. So I get my x-intercepts at 0, 0, 4, 0, and -1, 0. My y-intercept this time is also 0, 0. So plotting those x-intercepts and my end behavior, I connect my dots. And it looks pretty good. So interesting, we had only positive a values for these. Let's see if we can get a little bit more practice on our homework. I'll see you guys soon.